Hi, the example we have is a ball is projected vertically upwards from the ground with a velocity of 20 meters per second, and the questions are related to the motion of the ball, right? So when it comes to the kinematics, I always suggest that you draw a diagram representing all the parameters or the quantities that are given in the question. So a ball is projected vertically upward from the ground, so that is the ground level, right? And with a velocity of 20 meters per second. So it is initial velocity, which is 20 meters per second. So what is going to happen to the ball's motion is that it is going to go up. And once it reaches the maximum height, it will come down. Meanwhile, during this entire motion, there is going to be gravitational acceleration, which is pointing downwards. And in this case, it is said to be 10 meters per second squared, right? Um, so what are the other things that we know about the motion of this particle? So we know that when it has reached the maximum height, which is here, the velocity is 0. So we have seen why that is the case, because if there is a velocity, so we can say that the object always in motion as long as there is a velocity. So it is going up and it is turning down. So at that U-turn, or the point where it turns back, the velocity should be 0. If it had a velocity at that point, it should have gone further above, right? So the velocity at that point is 0. So the question is, how high will it go? So in kinematics, we have looked at 4 basic equations, right? So to revise those equations, first equation is final velocity is given by the initial velocity plus the change in velocity, which is calculated by accelerations time. The second equation is delta x or delta y. That's the displacement, is equals to initial velocity plus time plus half at squared. Third equation is final velocity squared equals to initial velocity squared plus 2a delta x. Delta x is for the displacement. It is not like the displacement, particularly in the x direction. And we have another equation that is not quite popular, but we do have the equation, which is vi plus vf divided by 2, which is the average velocity times the time. So remember, all of these equations are only applicable under constant acceleration. If you have different accelerations, you have to use these equations multiple times in the region where the acceleration is constant, right? So the first question we have is, how high will it go? So we need to know the displacement up until its maximum height, which is this. So I'm going to mark that as h max, right? So the easiest way is to understand what are the parameters we have to relate, what are the parameters we have, and what is we have to find out. So we have to find out the h max. That is the question. So we need an equation that has the displacement. So the first equation is not going to work because it doesn't have an equation. It doesn't have the displacement. And we know that we are going to use it from here to here. So I'm going to mark it from A to B. So always these equations are used from one point to another. So we're going to use it from A to B, right? For part A. And we have to choose what equation we are going to use. So we know the velocity at point A, which is going to be the initial velocity. We also know the velocity at point B, which is going to be the final velocity, which is 0. So we know the final velocity, initial velocity. We know the acceleration due to gravity. So we can use this equation because this has all the parameters that I know and that I do not know, which is the displacement, right? So I'm going to use V final squared equals to Vi squared plus 2a delta x. So I'm going to use it in the upward direction. So what is the meaning of this arrow that I put in front of the equation is that I tell anything in the upward direction is positive. If you want, you can go for the downward direction as well, right? So I'm going to use anything or any vector quantities that I have in this problem, which are upwards as positive. So final velocity is 0, which is the velocity at the top. Initial velocity is 20, so it is 20 squared plus 2. Acceleration due to gravity. So acceleration due to gravity is pointing downwards, right? Don't forget that it is always pointing downwards. So acceleration due to gravity is pointing downwards, but I'm considering anything up as positive, so it is going to be minus 10, right? Understand why it is minus. And delta x is my h max. So by rearranging this equation, I can find h max as 20 squared divided by 2 times 10. So that is going to be 400 divided by 20, 20, right? So the second part, how long will it take to reach the highest point? So now we need to find out the time. So we know the final velocity, we know the initial velocity, we know the acceleration due to gravity. So we can use this first equation for the second problem, right? You also can use its second equation, but I recommend not to use something that you found in the previous question, right? So if you are going to use this 20 in the next question, the problem is if you have made a mistake in finding this 20, you're definitely going to have a wrong answer for the second part as well. So here also I'm going to use it from point A to point B, and I'm going to use it in the upward direction, which is the first equation, which is Vf equals to Vi plus At. So the final velocity at the highest point is 0. Initial velocity is pointing upwards, so it is positive 20 plus acceleration is pointing downwards. So I'm considering anything up as positive. So it is going to be minus 10, and time is what I do not know. So time is 20 divided by 10, which is 2 seconds. There are shortcuts, or there is a shortcut to find this, and I will go through that shortcut in a bit, right? So the C part is when will it return to the ground, which is from point A to point B, and I'm going to mark it as point C, right? So I'm now going to use it from point A to point C, right? So I am going through point A to through the point B as well. So there is another thing that we know from previous examples that we have done, that if the particle that you have thrown in the upward direction reaches the same height, right? At the same height, the velocities or the speed would be the same, but the direction of the speed would be different. So velocity is reversed. So at this height, I know that the velocity is going to be pointing downwards and 20 meters per second. So that is something that we know from the previous examples that we have done. So I'm going to use it from point A to point C. I'm going to use the same equation that I used previously. So Vf equals to Vi plus At. I'm going to use it in the downwards direction just to be different, right? So don't get the understanding that you have to consider G, which is 9 or 9.8 or 10, as minus all the time. It completely depends on how you're going to use it. In this example, in the third problem, you'll understand why. So the final velocity, which is at point C, because C is the final point, the velocity is pointing downwards, right? Now I'm considering anything in the downwards direction as positive. So final velocity, I'm going to put plus 20. Initial velocity is pointing upwards, which is at point A. And I'm considering anything as downwards. So that is going to be minus 20. Acceleration is 10. Why is it not minus 10? Is because it is downwards, the acceleration, and I'm considering anything down as positive. So it is positive 10, right? Understand the difference. And we have the time. So if you rearrange it, you will get the time as 40 divided by 10 or 4 seconds. So this one, you could have simply you could have avoided doing this equation or this calculation, because if a particle has been thrown from a point and it goes up and it comes back to the same height, you should understand that whatever the time it takes to go up, which is 2 seconds, should be the same time for it to come back to that position as well, right? So since I know that it takes 2 seconds to go up, it is double the time that it takes to go up would be the time it would take for it to come back to the same position, right? So that is going to be 4. And the final part, which is with what velocity will it return to the ground? So we have used that as a known quantity, but if you do not know, right? Let me do the C part without the 20, right? So C part without the 20. So I'm going to use the second equation, right? Which is delta y. So I'm going to use delta y because delta x is generalized equation. But this problem, we are dealing in vertical direction. So I'm going to use delta y equals to the initial velocity t plus half at squared. So I'm going to use it from point A to point C. Since I'm using from point A to point C, there is no displacement because point A and point C are at the same height. So there is no displacement. Initial velocity, I'm going to consider anything up, pointing up as positive. So initial velocity is plus 20. Time is t. I do not know the time, plus half. Acceleration is pointing downwards, but I'm considering anything up as positive, so minus 10 t squared. So if you rearrange this, you will get 40t equals to 10t squared. So you can cancel this t and you can do this. So you get t as 4 seconds, right? So this is another method or another way that you could have found that 4 seconds. So I have told you one shortcut. I have shown you one equation, and this is another equation in which you could do the same thing, right? Now going back to the D part, I want to find the final velocity. So in that case, I'm going to assume that I did not know that the velocity at this point is 20. So I'm going to use it from point A to point C again. The equation I'm going to use is first equation, which is final velocity equals to initial velocity plus acceleration's time. I'm going to use it in the downwards direction. Since the object is coming down at point C, I'm going to use it in the downwards direction. But you can use it in the upward direction as well, as I showed you earlier. So final velocity, I do not know. Initial velocity is upwards, but I'm considering anything down as positive, so it is minus 20. Plus acceleration is pointing down. I'm considering anything down as positive, so that is 10. And time is 4 seconds, right? So that is minus 20 plus 40, which is going to be 20 meters per second. So which is exactly that I told we know from the previous examples, right? But in exams or in any tests, if you are asked to figure it out, then you have to do it this way. Okay.